Hello and welcome to the wide world of physics, where today we are going to talk about charge. We're going to talk about static electricity and how charges flow. And that is a really key concept on how we understand electricity working. So to do today's experiment, you need a few things. Nothing terribly hard to come by. You need a drinks can of some kind, just a regular aluminum can will do. You will need some kind of plastic rod or a comb. A plastic comb works best. Has to be plastic though. Plastic is very, very important for this. And the other bit you need is a few scraps of paper. Literally just any kind of paper, doesn't matter what kind. And from that, you can see how static charge will then move to then become charged particles. Now, like we were talking about before, we know about charged particles in the sense of we know that if you have some paper, the paper itself is not charged. There is no charge on the paper, it is neutral, it doesn't stick to anything, but things like the plastic from sweet wrappers or the film that's on, the plastic film on certain items, when you peel it off, will stick to your hand. And that is because it has a charge to it. Now, to generate a charge, you need to move some particles, specifically electrons, because protons and neutrons don't move. It's only electrons that move, and that's very key to how electricity works. But also, you can get it to move by doing something very simple. If you take just a regular plastic comb, run it through your hair a few times, you can actually move some of those electrons from your hair to the comb, okay? Or vice versa, depending on what kind of material it's made of. At which point in time, this comb is now charged. So, if you move it over the paper, you can actually get it to attract the paper to it. To give you a little better view, I've run this comb through my hair a few times, and if you just put it near the paper, you can get it to jump right up and attract right onto from the paper to the comb. And now what you're doing is you're inducing a charge in the paper that wasn't there before because the comb is now charged. And that's a very key concept to how we're going to look at it next. The other way of looking at this is a version of a magic trick where I have my magic wand and I can actually get this can to move without touching it. Now, how did that happen? How it happened was I took the rod and charged it through a bit of friction. That friction then got the electrons to move from the cloth onto the rod. It works the same way with the comb. The comb isn't quite as powerful with it, but it does work the same way. So if you don't have a chargeable rod or a piece of plastic coat hanger or a ruler or something like that, you can get it to work with the comb, but it doesn't work quite as well. It will work, but like I said, it's not nearly as powerful as the rod, because the comb will not hold nearly as much charge to move the can. Now, how does the can move? Well, what happens is you have the can itself, which is just a regular drinks can, okay? Standard aluminum can, nothing terribly shocking about it. But the thing is that force from the charge is actually attracting the can towards it. So you are putting a force onto that can to get it to move without actually touching it. Not once did I touch the can, there's no magnets involved, there's nothing involved other than the fact that this comb, or that rod, is indeed charged. That electrostatic force pulls the can towards the object. And that is how we begin to look at electricity. Thank you very much for watching, and if you enjoy watching these videos, please remember to like and subscribe and have a look at the other videos on this channel.